everyone, welcome back to the channel. In this video, we will discuss nuclear binding energy and mass defect, one of the most important topics for gate physics. This concept explains why nuclei are stable, why fusion and fission release energy, and it is frequently tested in numerical as well as conceptual question. By the end of this video, you will clearly understand the physics, the graph, and how to solve gate problems. So let's start. The first question is why nucleus is bound? We will find the answer here. As you can see, this diagram shows binding energy per nucleon plotted against the mass number. Here, if we see with the light nuclei, binding energy increases rapidly with increase in mass number. This happens because the strong nuclear force is short range and attractive, and each added nucleon finds many neighbors within this short range. As a result, the total attractive nuclear interaction increases and energy is released during the formation of these nuclei. In other words, energy is released whenever a nucleus moves toward higher binding energy per nucleon. As we move towards the medium mass, that is iron 56, the attractive nuclear force and repulsive Coulomb force are optimally balanced at this point, which makes iron more stable nuclei. Now, as we move towards higher mass nuclei or heavy nuclei, although the strong force is still present here, it is short range and it saturates. It doesn't increase significantly with the size. However, Coulomb repulsion between protons is long range and keeps increasing as more protons are added. This reduces the binding energy per nucleon for heavy nuclei like lead. Therefore, this single curve explains why energy is released in fusion of light nuclei and why heavy nuclei can release energy through fission, and how nuclear stability arises from the competition between short range strong nuclear force and long range Coulomb repulsion. Okay, now we will see what is mass defect. The actual mass of atomic nucleus is always less than the mass of protons and neutrons present in the nucleus. When a nucleus is formed, energy is released, and this energy is removed. In the form of reductionist total mass, or we can say the missing mass. This missing mass is known as mass defect, and it accounts for the energy release. Mass defect is denoted by this term, where C represents number of protons, M represents mass of protons, and the mass defect can be calculated by subtracting the original atomic mass from the sum of mass of protons and neutrons present in the nucleus. So this is the equation which presents how we can find the missing mass or the mass defect. Please don't forget to subscribe my channel. Now let's see what is binding energy. We know this famous expression, E is equal to mc square. The mass defect corresponds to energy called the nuclear binding energy, and binding energy is the energy required to completely separate a nucleus into free protons and neutrons. A higher binding energy means a more stable nucleus. In nuclear physics, binding energy is usually expressed in megaelectronvolt, not joules. And always remember, this is the most important tip. Always convert atomic mass unit to MeV. And 1 atomic mass unit is equal to 931.5 megaelectronvolts. Now let's see what is fission and fusion. For light nuclei, fusion increases binding energy per nucleon, and this extra binding energy is released as fusion energy, which powers the sun and stars. For heavy nuclei like uranium, splitting the nucleus increases binding energy per nucleon, and this released energy is called fission energy, used in nuclear reactors. So nuclear energy is nothing but a consequence of moving toward higher burning energy per nucleon. And now we will solve some numericals, and let's see what we are gonna do with this numerical. We have given the mass defect and binding energy for helium nucleus. We have to find mass defect and binding energy for this. So in the first step, we will calculate the number of protons here, and proton mass is given, number of neutrons and neutron mass is given, and mass of helium nucleus is given. So we already studied this equation in the previous slides. We will substitute the values and we will get the mass defect. It's quite simple problem. In the next step, we know we have studied E is equal to mc square, and binding energy we have just calculated and we have multiplied by just to convert into mega electron volt. This is the final answer. Okay, now what we have learned here in the whole video, mass defect is the missing mass converted into energy. Binding energy determines nuclear stability, and iron 56 is the most stable nucleus. Fusion and fission are explained by binding energy curve. Always remember, one graph is equal to multiple concepts. And numerical equations are easy if concepts are clear. If you find this video useful, like, share, and subscribe for more videos like this. And thank you for watching.